Welcome once again, class. Thank you for joining me for our next notes video. Today in 11.3a, we're going to be talking about dividing rational expressions. So our objective, we are working on dividing by a monomial. And again, what does a monomial mean? Well, monomial means dividing by a single term, okay? Just a variable being multiplied by a number. That's what a monomial means, and that's what we're going to divide by. Now, to begin, we're going to do a little bit of review first. Okay, so we've done two things so far, multiplying rational expressions and then dividing these rational expressions. So to review multiplying, remember the first most important thing, factor, factor, factor. I can't stress that enough. So we're going to factor both of these to begin. Looking at the x squared minus 36. This is a special one. It's a quadratic, but notice it only has two terms and they're being subtracted. Also notice they are both perfect squares. So remember, that is our difference of squares case. X plus 6, x minus 6. And I did not leave myself enough space here. All right, so don't forget how to go back to those special cases. This x squared minus 1 is that same special case. It's a quadratic, and the two terms are being subtracted, but notice they are both perfect squares. So we get x plus 1, x minus 1. All right, now, notice I was really nice here. The top is already in factored form for you. So you actually don't have to do anything with that next one. However, notice 2x plus 12 is linear and has two terms. With linear things, the only thing we can possibly do is pull out a greatest common factor. And from there, a 2 pulls out from both terms. So again, one of the most important things is our ability to factor, even remembering some of those special cases, those difference of squares. Now that I've done this, now what I'm going to start looking for is things that cancel on the top and the bottom. So I notice x plus 6, x plus 6, x plus 1, x plus 1, 2, and 2. After slashing all of those out, the only thing I have left on top is x minus 6. Only thing I have left on the bottom is x minus 1. And that is going to represent my end result there, my final answer. Now, after multiplying, we started talking about dividing. So when we're dividing two fractions, remember, the goal here, first and foremost, simply rewrite it. That's our first step. We're always going to rewrite the problem. So, once I've rewritten my problem, now I begin my factoring process. Even in these division ones, remember, factor, factor, factor. The most important skill to have for this chapter. So, let's take a look at this first one, quadratic trinomial. All right, so that means I'm going to be getting my two parentheses. So, that x squared means I'm getting x and x. Two things that multiply to negative 30 and combine to negative 1. So if I'm looking for those, my combination is going to be negative 6 and positive 5. 2x plus 10, this is something linear. And again, the only thing we can do with linear things is see if there is a greatest common factor that can pull out. In this case, a 2 can pull out. So we have 2, now we're left with x plus 5 there. 4x squared, well, a single term, you can't factor. So there, we're just going to rewrite it. This x squared minus 36, we've already done that. Up in the first problem, we already discussed difference of squares is a quadratic, and it's being subtracted. Both terms are perfect squares. So when that happens, remember your x plus 6 and then your x minus 6. So once I have everything fully factored, now I start looking for what can I cancel. X minus 6, x minus 6 cancels out. X plus 5 cancels out. 2 and 4. When I look at those, 2 over 4 reduce, or 4 over 2 reduces to 2 over 1. So when I'm looking for what I have left, on top, I have 2x squared. On the bottom, I have 1 times x plus 6. And so that is going to be my reduced rational expression. So again, that's just review of how to tackle when you're multiplying or dividing two rational expressions. Today, we're going to switch our focus. Today, we're going to talk about what happens when we have any polynomial if we're dividing by a monomial. And again, by monomial, I just mean a single term, a variable with an exponent times some number. That is a monomial. And the cool thing is, these are actually relatively simple to do. All you have to do is split it up. What I mean by that is when you're dividing by a monomial, all you have to do is take every individual term and divide it by that monomial. So all you do is rewrite it in 3 separate pieces, because now you can simplify each piece individually. So if I'm looking at my first piece, 9x cubed, 3x squared. Well, 9 divided by 3 is 3. X cubed divided by x squared. So I'm starting with 3, taking away 2 of them. That just leaves me 1 of them. Look at my second one. 6 divided by 3 is 2. X squared divided by x squared. Well, I'm starting with 2 x's, and I'm taking away both of them, so I don't have any x left. Look at my next one. 15 divided by 3 leaves me 5. X over x squared. So I have 1 on top, and I'm taking away 2. So remember what that means. There's a difference of 1 there. So I'm going to have 1 left in the denominator, because 1 minus 2 is a negative 1. So that means I have 1 left. However, it's in the denominator. And that's all you actually have to do for these. Okay, that is it. So, looking at our next one. First off, I'm going to fix the little typo that's in here. That a to the a, that really should be an a squared. So first I'm going to fix that to make it less awkward to look at. But now we're going to solve this exactly the same way that we solved the other one. So, the first thing that I'm going to do is I'm going to write this out. I'm going to split everything up to divide each term individually by that denominator. Oh, not x. That should be an a. All right, so once I split it up, now I'm going to simplify each piece. So I'm going to start with that 4a cubed over 2a squared. Well, 4 divided by 2 is 2. a to the 3 divided by a to the 2. 3 take away 2 leaves me an a to the 1. 10 divided by 2 is 5. A squared, take away a squared. 2 take away 2, you don't have any left. You have 0. And now our final piece, 3 divided by 2, well, actually just stays a fraction. That can't simplify. A divided by a to the 2. 1 to take away 2 leaves you with a -1. So that -1 means we have an a left, but it's in the denominator. And that is actually it, all that we have to do. So please make sure you have all of this written down. Thank you for joining me for these notes, and so come back to class prepared, please, to begin our practice work.